Well, hello everyone. This is another one of the short videos in my series for my ITS2300 data networking class. And this video will talk about both DHCP and Autoconfiguration. So as usual, we are going to hop into the table of contents of the TCP/IP Illustrated book that we've been reading along with the class. DHCP and Auto Configuration is Chapter 6. There are there's a lot of detail in this chapter. It talks about all the details of how the protocols work and how the packets are structured. For our first pass through, that's more detail than we need. In particular, some of the packet formats and things for this particular class we'll examine using our lab environment, and Wireshark will actually look at our own packets rather than looking at them printed here in the book. So as usual, here's the table of content, and make that one step bigger. So in Chapter 6, obviously read the introduction. You want to read about the overview of the protocol 6.2 and the bit about address pools and leases, because as we talked about DHCP 6, and we'll talk about DHCP, which is what this is, has to keep track of addresses. We'll then skip the message format, the options. You want to read 624, the protocol operation. It's about a page that shows the exchange of what types of messages go back and forth. So that's super useful. You want to give DHCP v6 a quick read. We don't need a ton of detail, but talk a little bit about the differences between DHCP and DHCP6 without getting into, I think, too much detail. Then we will definitely skip a lot of the remainder here for DHCP. So we're not going to worry about relays. We talked about it a little bit, and something you should remember exists, but we don't need the details. Authentication, reconfiguring, rapid commit, location information, mobility, and handoff. Well, we might get a chance to look at the very end of the semester, and DHCP snooping we don't need either. You do want to look at 6.3. Talks about stateless address auto configuration, what you want is the overview of the IPv4 case, which is where those 169 addresses come from, but you've seen in the lab every now and then. You want to look at IPv6 SLAAC. So it talks about some detail about how this works for the link local addresses, which are addresses that are just used on the same subnet without a router. What you're really looking for, and it's not shown at this level of detail, there's a section below this that talks about IPv6 SLAAC auto configuration for global addresses, and you want to read that, and it will sort of give you the contrast between how we do this in IPv4 and how we do this in IPv6. And then the remainder of the chapter, other than the summary, I always suggest you look at the summary just to see if there's anything useful that helps you kind of put things in context. But the remainder, DHCP DNS, PPP over Ethernet, and attacks, because we're not talking about security just yet, you can skip over those. All right. So then in the rest of the video, let's summarize a bit about how we do this, and I need to go grab my tablet real quick. There we go. So I really am not very good at drawing on a Jamboard with a mouse. That just isn't happening. So this is a much nicer way for me to do this, but I hadn't set it up when I started. All right, so there's a huge difference. So the whole idea here is I have the whole idea is I have a router, and we're going to look at that general case where we have a router, we have a subnet, we have several hosts, and I want to find good ways to have these hosts acquire the necessary information they need automatically, right? And so the information we want is they need to know an address. They need to know what subnet they're on. They need to know where their router is. And they need to know their DNS server so they can resolve names. And some devices need more than this, but this is the minimum that will get us going. And so for something like a laptop or a desktop, this is what we want. All right. So how do we get this? And the big difference between IPv4 and IPv6 is that in IPv4, we are limited in the number of addresses. So IPv4 has a limited number of addresses. I'm going to say limited address space. Right? So even something is, so we know we only have 32 bits. So even something like a /16, which you were playing with in the private space, has like 65,000 addresses. More likely you'll, but that's all that OU has in an IPv4 address space. And that's of course then subdivided between buildings and such. So ultimately, in IPv4, my address space is limited. I have, hopefully comfortably more addresses than I have devices, but not a whole lot more. So I have to actually do bookkeeping. And so the DHCP server, which I'm just going to show as sort of being attached via the router here. So my DHCP server for IPv4 has to keep track of addresses. So when the protocol operation, the host will send a broadcast that asks for any available DHCP server. The DHCP server will then reply and say, I can provide information. The host will then send a request, which normally says, I want this stuff, and if it needs anything else, it'll ask for it. And then the DHCP server will look at its address pool, and you guys did configure an address pool in one of the labs. We'll look at its address pool, find an unused address, send it out to the host saying, here's your information, including an address. Then the host acknowledges and said, okay, I'm going to start using that address. The DHCP server now has to mark that address used. It's called a lease, and so it's in the reading. We talked about it a little bit, and you looked at the listing of DHCP leases in in one of the labs. So the DHCP server now has that address marked as used. It gives an expiration time. If it doesn't hear back from the host by that time, it will mark the address as available again. If a host shuts down properly, it will actually send a message saying, "Hey, you can give up. You can use that address again. I'm done." Those kinds of things. So that's because I have to be very, very careful managing my address space. I need to be very cautious. And so that's the DHCP operation. Now, in contrast, in IPv6, addresses are essentially unlimited. And we've not talked about IPv6 a great deal, but in IPv6 we have 128 bits the longest prefix, actually the usual prefix used for a subnet is /64. So you have 64 bits to 64 bits to address an individual host on a single subnet. And so you can have vastly by many orders of magnitude more devices on a single subnet than are in the entire IPv4 internet. So the difference is absolutely immense. And so the takeaway is that in IPv6 we don't manage addresses generally. We manage networks. And so once I've assigned a subnet to this guy here, to the router, an IPv6 prefix, there's a vast amount of address space available for the host, much more than many more addresses than I could ever plug in. And so in IPv6, the default, as an administrator, I can configure my network differently, but the default is that the host, as soon as you turn it on, will simply randomly pick an address. In the address space, it will use a special prefix called the link local prefix. So these addresses will not go beyond a router. No router will route them. They're useful to communicate back and forth between hosts on the same network. Again, like we talked about, maybe attached storage devices or a printer or something like that, where you really don't need the router. So that happens automatically, and in fact, when you did IP configs on your Windows machines in the labs, you always saw those things pop up. They start with FE80, and so that the chapter in the book, the section of the book that talks about link local addresses will talk about that. So addresses starting with FE80 are link locals. So those happen automatically. You don't have to do anything, and I don't think you can turn that off. That always happens. But in IPv6, unless I configure things otherwise, I set the router up to send something called a router advertisement. It's called an RA message. And it's a very simple message that just gets broadcast for all practical purposes across the network that identifies what subnet we're on and where the router is. And knowing those two pieces of information, the host then uses kind of the same process to build an address. So the address is actually not handed out. Nobody keeps track of who is using what address. The host just creates its own address. Now, even with a huge address space like this, you could, in theory, end up with two hosts that accidentally pick the same address. So there's a little bit of a mechanism in place that's designed to avoid that. So basically, once a host picks an address for itself, it does the equivalent of ARP and says, hey, does anybody have this address? And if it gets an answer, it knows it's screwed up and it needs to assign itself a different address. But if that doesn't happen, then it knows it can use that address. Nice thing here is that I don't need a server with persistent storage, right? This DHCP server for IPv4, the DHCP server for IPv4 has to keep track of those leases. In IPv6, nothing keeps track of leases. They just kind of come and go, and I really don't care because I have plenty of address space. There's a little bit of a quandary here because I'm missing a piece of information, right? So I'm going to mark this with so the address is automatic. The host just makes it up. The subnet and the router it got through the router advertisement, but it didn't get told about a network, a DNS server, and it didn't get told about other things that it might need. Some of the more specialized information that some devices might need. So I could run a DHCP 6. DHCP 6 server. This one will still not track leases. It doesn't need to, but it would basically, by request from the by request from the host, it will basically return all the other information, including DNS. Because DNS is kind of the only thing that's missing, and it is the only thing that's really like every device needs. There is an one of the standards includes an option to include the DNS server address in the router advertisement. There's a fair, and remember, our book is several years old, and it talks about there being some controversy about how to do things, and that controversy persisted all the way to today. Right, because what's going on here is I have this RA mechanism, router advertisement mechanism, that I can use to configure a host, and I also have DHCP 6, and I can configure a host. And a lot of engineers, standard writers, don't like the idea that there are two different ways to send out the same information. What if it's not in sync, or what if it gets out of sync, and this one hands out different information from this one. DHCP 6 has some interesting properties that DHCP 4 doesn't have, that go beyond what we can talk about here, and using RA sort of defeats that. You don't lose those options. So it's an engineering dispute, but both of these options exist. So DHCP v6 is actually, in some ways, quicker and easier to get up and running, because you don't, with that option configured into the router, you don't even have to set up a DHCP server, which is kind of nice. All right, so this is kind of a quick run through of auto configuration. And the way that works on either IPv4 or IPv6. So thanks for watching, and I will see you in the next video.